Hello students, let's proceed with polynomials, exercise 2.2, section 3. These sums are going to be based on finding the zeros of polynomials. So let's take a look at the first one. You have a polynomial px is equal to 3x plus 1 and you have to find whether x is equal to minus 1 upon 3 is the zero of the polynomial, which means at x is equal to minus 1 upon 3, do we get the value of polynomial p as 0? Let's go ahead and solve. All the remaining sums are based on the same concept. So px is equal to 3x plus 1 for x is equal to minus 1 upon 3. Your polynomial becomes p minus 1 upon 3 is equal to 3 into minus 1 upon 3 plus 1, right? 3 ones are 3, 3 ones are 3. I am left with minus 1 plus 1, which is equal to 0. Therefore, p of minus 1 upon 3 is 0. Therefore, minus 1 upon 3 is the 0 of the polynomial px is equal to 3x plus 1. Similarly, I am going to solve the rest of the sums. So the second sum is px. So this is a polynomial in variable x given by 5x minus 5x minus pi. I'm sorry. And you have to check for x is equal to 4 upon 5. So for x is equal to 4 upon 5, I am simply going to go ahead and substitute x is equal to 4 upon 5 in the polynomial expression. So p of 4 upon 5 will give me 5 into 4 upon 5 minus pi. 5 ones are 5, 5 ones are 5. So this is 4 minus pi. This is not equal to 0. So p of 4 minus 5 is not equal to 0. Therefore, 4 upon 5 is not a 0 of polynomial or 0 of polynomial px is equal to 5x minus pi. We'll go ahead and quickly solve the third sum. However, I think in the third sum, yes, in the third sum we have to find for two values of x. So I'm just going to go and write my question first. Px is equal to x square minus 1. And you have to find for values x is equal to 1 and x is equal to minus 1. Let's find for x is equal to 1. Substituting x is equal to 1 in this expression, that is in the polynomial expression, I get 1 square minus 1, which is 1 minus 1, which is equal to 0. Correct? Therefore, 1 is the 0 of polynomial px is equal to x square minus 1. Right? Now let's check for minus 1. Substituting x is equal to minus 1 in the polynomial expression x square minus 1, I get minus 1 the whole square minus 1, which is minus 1 square is 1 minus 1, which is 0. So p of minus 1 is 0. Therefore, minus 1 is the 0 of polynomial px is equal to x square minus 1. Let's take a look at the fourth sum. A polynomial is Px is equal to x plus 1 into x minus 1. And like the previous sum, we have to check whether we have zeros of polynomials for different values of x, 2 values of x. So for x is equal to minus 1 and x is equal to 2. I am going to do it one at a time. Let's find for x is equal to minus 1. Substituting x is equal to minus 1 in this polynomial expression, I get p of minus 1 is equal to minus 1 plus 1 minus 1 minus 1, which is minus 1 plus 1 gives me 0 into minus 1 gives me minus 2. That means you are adding these two terms because of similar signs and sign of the greater number. Now there is no really a greater number, both are equal, so you take any one of these. So minus 2 anyway, so 0 into minus 2 is going to give me 0. So p of minus 1 is giving me 0. Therefore minus 1 is a 0 of polynomial Px is equal to x plus 1 into x minus 1. Correct? Let's check for x is equal to 2. P of 2 is equal to, substituting x is equal to 2 in the above expression, you get 2 plus 1 into 2 minus 1, which is 2 plus 1 is 3. Rules of BODMAS, I am solving what is there in the brackets first. So 3 into 2 minus 1 gives me 1. 3 into 1 gives me 3. So p of 2 is equal to 3, which is not equal to 0. Therefore 3 is not a 0 of polynomial. I am sorry, 3 is the answer, 2 is not the 0 of polynomial. Of polynomial Px given by x plus 1 into x minus 1. Okay. Let's take a look at the fifth sum. Similar concept, Px is equal to x square. So this is going to be a very simple one. Px is equal to x square, and you have to find whether 0 is the 0 of the polynomial. You have to find for x is equal to 0. So for x is equal to 0, I am going to substitute x is equal to 0 in this expression. P of 0 is equal to 0 square, which is equal to 0, right? Therefore 0 is a 0 of polynomial Px is equal to x square. Let's take a look at the sixth sum. Your polynomial is Px is equal to Lx plus m, and you have to check for x is equal to minus m upon L, right? So for x is equal to minus m upon L, I am going to substitute minus m upon L in the place of x, right? Because this is a polynomial. Now you will be confused whether where you have to substitute the value of minus m upon L. So the first hint is x. You have to substitute for x, right? It's mentioned in the question as well. And this is also the other hint. It's a polynomial in variable x. So in this polynomial, only x is considered as a variable, whereas L is the coefficient which could be a constant, and m is also considered as a constant. So only in place of x am I going to substitute the value minus m upon L. Clear? So P minus m upon L is going to be L into minus m upon L plus m. So if this was say 1, or if the value of L was 2, so 2, 2. But this is the same term, I am just going to cancel. L 1s are L, okay. So I am left with minus m plus m, right, which is equal to 0. So P of minus m upon L is equal to 0, correct? Therefore your answer minus m upon L is a 0 of polynomial Px is equal to Lx plus m. I have solved two sums on the board, so take a clearer look. This is P. Do not get confused with the overwriting. Okay, I will solve the last two sums now. So the seventh sum, Px is equal to 3x square minus 1, and you have to check for x is equal to minus 1 upon root 3 as well as 2 upon root 3, right? So for x is equal to minus 1 upon root 3, I am simply going to substitute. This negative is not clear, let me write it more clearly for you to understand better. I am simply going to substitute x is equal to minus 1 upon root 3 in this entire expression. So this becomes P of minus 1 upon root 3 is equal to 3 minus 1 upon root 3 the whole square minus 1, correct? Minus, the square of minus is positive, so this becomes 1 square is 1 upon root 3 square is 3 minus 1, right? This is nothing but 3 1s are 3, 3 1s are 3, 1 into 1, 1 minus 1, which is nothing but 0. So P of minus 1 upon root 3 is 0. Therefore, minus 1 upon root 3 is a 0 of polynomial Px is equal to 3x square minus 1. I do not have much space to solve the second section, so I am going to erase x is equal to minus 1 upon root 3 and just solve the second part, which is 2 upon root 3, right? Again, substitute the value of x as 2 upon root 3 in this expression. You get P of 2 upon root 3 is equal to 3 into 2 upon root 3 the whole square minus 1, right? 3, the square of 2 upon root 3 will be 2 square is 4 and root 3 square is 3 minus 1. 3 1s are 3 and 3 1s are 3. So I am left with 4 minus 1, which is equal to 3. Now this is not equal to 0. So P of 2 upon root 3 is not equal to 0. Therefore, answer 2 upon root 3 is not a 0 of polynomial Px is equal to 3x square minus 1. Okay. Now the last sum for section 3. Which is the 8th sum, okay. A polynomial is a simple one. Px is equal to 2x plus 1, and we have to check whether x is equal to 1 upon 2 is a 0 of this polynomial. Again, following the same procedure, I am going to substitute for x is equal to 1 upon 2 in this expression, that is the polynomial expression, I get P 1 upon 2 is equal to 2 into 1 upon 2 plus 1, right? So 2 ones are 2, 2 ones are 2, 1 into 1 is 1, 1 plus 1 is 2. Okay, this is not equal to 0. So P of 1 upon 2 is not equal to 0. Therefore, answer 1 upon 2 is not a 0 of polynomial. What's the polynomial? Px is equal to 2x plus 1. With this, we conclude the third section of exercise 2.2. We will cover the remaining topics in the coming lectures. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.